Hello all, in this video we are going to study about aromatic acids. Now in the name itself it has aroma. Aroma is nothing but the acids or the group of organic compounds that possess of specific odor, specific smell. So these are nothing but the class of organic compounds that contain carboxyl group, that is C double bond OH attached to an aromatic ring. They are important in nature as they are found in many fruits, vegetables and plants, and also have various industrial and commercial application. They can be also used in food additives, pharmaceutical dyes as various preservatives. A common example of this group is your acetic acid, your vinegar, which we use for the preparation of various food items. It belongs to the class of carboxylic aromatic compounds. Further, here we have some examples such as benzoic acid. Here in this video we are going to stretch more about benzoic acid, its various synthesis and reactions. We also have few other examples as 2-hydroxybenzoic acid, hydroxyl group attached, amino group attached to amino benzoic acid, phthalic acid, 2-methyl benzoic acid, and 3-nitrobenzoic acid. Let's study about the various synthesis or preparation of aromatic acids. There are a number of ways to prepare aromatic or benzoic acid. The few methods are oxidation of benzyl chloride, reaction of phenyl magnesium bromide with carbon dioxide, hydrolysis of benzonitrile, basic hydrolysis of benzotrichloride, and hydrolysis of phenyl benzoate. Moving with the first, that is oxidation of benzyl chloride. Here you can see benzyl chloride on hydrolysis gives you benzyl alcohol, which on reacting with oxidizing agent potassium permanganate gives you corresponding benzoic acid. If you understand the mechanism here, you have a benzyl chloride which is dissociating as CH2 and Cl minus. Here the water is dissociated as H plus OH minus, so this hydroxyl nucleophile is attacking on this CH2 and is forming an alcohol, benzyl alcohol, which is further reacting with the potassium permanganate, a strong oxidizing agent, to give you the benzoic acid. The second synthesis is reaction of phenyl magnesium bromide with carbon dioxide. Here you can see phenyl magnesium bromide when reacted with carbon dioxide is giving you magnesium benzoate bromide, which on hydrolysis is giving you benzoic acid. This magnesium bromide is replaced with the carbon dioxide and further on hydrolysis giving benzoic acid. Further, acid hydrolysis of benzonitrile, C triple bond N is nothing but nitrile functional group. So on attached on benzene group it is benzonitrile. It is on simple acid hydrolysis giving benzoic acid. Water dissociating here as H plus OH minus. So this H is attacking to the nitrogen, so it is forming NH. OH is attacking to the carbon, so it is forming OH. You know, when new bonds are formed, old bonds break. So here the bond is break and a new bond, that is with OH, is formed, which is on acid hydrolysis further giving you carboxylic acid and ammonia. The byproduct is ammonia. Next is basic hydrolysis of benzotrichloride. Here you are reacting toluene with chloride, and which is giving you carbon trichloride and sodium hydroxide with water. When you are treating it with base, it is given sodium salt of benzoate, right? Sodium salt of acetate, and on acid hydrolysis it is giving you further benzoic acid. Here you can see the base is dissociated as Na plus OH minus. This OH minus is attacking here, and you can see this one chloride ion is replaced with the hydroxyl ion, and on hydrolysis it is giving your benzoic acid. Hydrolysis of phenyl benzoate. This is your phenyl ring, this is your benzene ring, and this is your extra oxygen, which is OH. So phenyl benzoate on hydrolysis is giving you benzoic acid and phenol. This is a commercial reaction which is giving you a byproduct as phenol. This phenol is used for various other applications and formation of other chemical moieties. So it is said to be a commercial reaction. Next are the reactions of aromatic acids. We have 5 to 6 basic reactions of aromatic acids. First is the salt formation, ester formation, acyl halide formation, reduction of benzyl alcohols, decarboxylation, and the main and important electrophilic aromatic substitutions. First is salt formation. Simply here you will synthesize various other chemicals or compounds from benzoic acid. So here you are taking benzoic acid in the presence of a strong base sodium hydroxide, which is giving you sodium salt of acetate, okay, which is sodium benzoate. And this benzoic acid is treated with base. It forms sodium benzoate plus water. This is nothing but a neutralization reaction wherein salt and water is formed. Next is ester formation. This is a main reaction as esters are formed. Esters are of fruity smell and fruity flavor. So these are used in the pharmaceutical preparations of syrups, various candies and dyes, etc. This is your benzoic acid in the presence of alcohol and sulfuric acid. It is giving you the corresponding ester as ethyl benzoate. Next is formation of acyl halide. Acid here is reacting with phosphorus pentachloride to give you benzoyl chloride. Okay, and you have your phosphoryl chloride with hydrochloric acid as a byproduct. So you can see here benzoyl halides are formed from benzoic acid. Here I have taken pentachloride, so benzoyl chlorides are formed. Next is reduction of benzyl alcohol. So lithium aluminium hydride is a strong reducing agent which is reducing benzoic acid to benzyl alcohol. Alright. Decarboxylation. In decarboxylation, the benzoic acid in the presence of calcium carbonate and sodium hydroxide is giving you a benzene ring and calcium carbonate. This calcium carbonate can be also used for other pharmaceutical applications. So this is decarboxylized to form benzene. Next we have electrophilic aromatic substitution. There are 5 electrophilic aromatic substitution in case of benzene, that is halogenation, nitration, sulfonation, and 2 more, that is Friedel-Crafts acylation and Friedel-Crafts alkylation. But here your aromatic acids, benzoic acid, do not undergo electrophilic substitutions. Why? We'll take an example of nitration and understand. Here aromatic carboxylic acid not only show acidity as expected to carboxylic acid, but they are slightly stronger than acetic acid. Now the carboxylic group here is deactivating. Deactivating meaning it is meta-directing. Other chemical entity or other substitution or other group on this benzoic acid will attack at which position depends on the functional group attached prior. So your carboxylic acid is attached which is deactivating, that is these are the compounds which deactivate the aromatic ring. That means they attack at meta-directing position and they deactivate. Whereas you have its opposite activating which activate the benzene ring and attack at ortho and para position. So you can see the incoming entity will enter a position meta to the CH group rather than ortho and para position. As you can see here, In nitration, benzoic acid in the presence of nitric acid and sulfuric acid is giving you all 3-nitrobenzoic acid. Similarly, you have for halogenation, benzoic acid will react with halogen and will give you all halogen group. Okay, that can be chlorobenzoic acid, fluorobenzoic acid, bromobenzoic acid. Similarly, for sulfonation, it will give you sulfonyl benzoic acid, etc, etc. So here we end our video. I am sure you hope you understand this video. Thank you. Please subscribe to my channel, and I'll be soon uploading the activating and deactivating series. So wait and watch. Thank you.